Okay, great. Well, thank you, Roberta, and thanks for the opportunity to give this talk. I'm glad that she mentioned that everyone's supposed to be leaving the building on purpose afterwards, so I don't think it's just a reflection on, the quality of my talk. So I'm Calen Henderson, as I mentioned earlier, and I'm going to switch gears now and not really talk about specific science results or anything along those lines, but I'm going to put on my archive hat. So 2 months ago, I started a staff position at IPAC here locally, working with NExSCI. As people have mentioned, it's a NASA Exoplanet Science Institute, and I work specifically for a project called the NASA Exoplanet Archive. Even just in the past 10 weeks since I've gotten started working with the different projects and the different tools, I have learned a lot about the exact resources and data hosting availabilities that are done locally here. And so I figured it was a good opportunity to tell everybody just generally about the archive, and I'm going to specifically highlight some of the microlensing specific resources that we have. Oh yeah, just to mention a couple other names because some of these people will be popping in and out throughout the workshop. The current director of the archive is Rachel Akeson. She's not here right now, which is good, so if I say anything wrong, I won't get in trouble. But it's about to switch to David Ciardi at IPAC. Solange Ramirez is a deputy director. The other archive scientists, along with myself, are Jesse Christensen, who's done a lot of excellent work with Kepler and K2, Julian Van Eycken, who's done a lot of FLARE work as well, Sergio Fajardo Acosta, and then the rest of the Exoplanet archive team. So I'm not the only person by any means who's involved in any of the tools that I'm about to present. So brief overview, what is the archive? What does it do? What are the resources we provide? So in kind of a rough dichotomy, there are data sets, and then there are analysis tools in browser that people can use. Every week, we're updating and ingesting new parameters for new exoplanets that have been discovered, going through AstroPH, and then also looking for planets whose parameters have been updated by follow-up studies. We also host a bunch of ground-based time series as a repository for SuperWASP, Kelt, HatNet, Trace. Those are just to name a few. And one thing I'm going to specifically highlight is UKIRT, and I'll go into more detail about that later as it relates to microlensing. Also space missions, Kepler K2, Corot, pipeline products from the Kepler primary transit mission, and then other contributed data sets. So a relatively new addition is the inclusion of transmission spectroscopy data files and these kinds of resources. As far as tools, I'm really not going to talk in too much detail about these. I could spend probably 10 minutes on every single one of these items, and this is an incomplete list. But I will highlight at the bottom ExoFast. This is a combined radio velocity but transit light curve fitter. It was the original seed of the code was written by Jason Eastman, who's now in Boston and working, I think, with Minerva now. And a lot of people, well before I got involved, the past at least year, maybe even longer, have been working to present a front-end user interface online through the archive where you can upload data and run all kinds of fits using the ExoFast software suite. And then I'm not going to talk about this beyond this slide because we're just going to interact with it pretty soon, is the PyLima fitting tool. So this is the actual code that Etienne Bachelet and Rachel Street at LCO have developed and have kindly allowed us to disseminate for use at this workshop to do microlens light curve fitting. And we are eventually, in a way that's analogous to this ExoFast RV in transit light curve software suite, going to be incorporating PyLima into the tools that are available on the archive as well. And I put the URL here just in case everyone has really fast typing hands. So the first main thing that I want to talk about as far as database management is what's called the confirmed exoplanets table. So the rest of this talk is going to be mostly a series of screenshots that I've taken of the various interfaces that we have at the archive and trying to help you walk through them. Where are they? How do you find them? How do you use them? This is the front page of the Exoplanet archive. And I took this picture early this morning. And we recently hit a big milestone. And by we, I mean the general exoplanet community. And that there are now over 3,500 confirmed exoplanets. So very exciting kind of news item here. This is our news box. And then we also have a ticker up here that tells you how many confirmed planets. And we keep track of other just high-level statistics up here. Through the front page, you can access what I was referring to as the confirmed planets table. So you can click on it here. You can also find it down here. And you can also interact with it by searching for specific targets, either by a planet name, doing a cone search, or even doing a more specific advanced search. And what this brings you to is an interactive table with all of the known exoplanets, that we have culled from the literature through AstroPH and those not on AstroPH, but in ADS, and gobs and gobs, those are metric units of columns, I should say, with different parameters for all of the known confirmed exoplanets. Let's see. Yeah, so one of the many things you can do is you can sort by columns, you can rearrange columns, you can, see if I put a thing for this. Yeah, you can do numerical searches for different quantities. So something you could do is filter on semi-major axis, planet mass, and eccentricity. And there you can just find all hot Jupiters that have eccentricity of a certain value, and you limit your search that way. And so it's very easy to play along, kind of search through the data just in tabular form of what humans know about exoplanets, which is very cool. Then the default table that is displayed is actually just a subset of the total number of columns of information that we have about all of these planets. And they're grouped in logical ways, and you can go through and see what is the equilibrium temperature, what is the mean density, these kinds of things, anything that's not even by default displayed. Yes, Mike, you have a question. Yes, Tiffany's nodding her head, so yeah. Yeah, I think you can remove, yeah, exactly. See, my example is even smarter than I thought. Yeah, so you can do not null, and that's going to do, yeah. And so this is maybe a bad example to have done that on eccentricity. These are measured values of 0, not null values of 0. Yeah, good question. Let's see. Oh, yeah. And even related to that, so if you find yourself returning to the archive and you have specific parameters you want to search and whatnot, you can actually create an account, and you can use that to go ahead. Yeah, so if your name is my email, I'm sorry, I gave away your email address. And you can go use that to actually save preferences, so specific ordering of columns. You can click and drag these left and right if you have a preferred column ordering, save different cuts, etc., so that you can return, load these. And here's just a couple examples. This is actually from Julian Van Eycken. You can see the kind of hint up there. You can look at hot Jupiters with certain eccentricities, confirmed Kepler planets that are in the habitable zone, so stellar insolation is one of the other parameters, et cetera, et cetera, et cetera. I think you all get the idea. Yeah, so one example. And then using either a saved kind of tabular designation or just interacting it without logging in, you can also plot whatever cuts you've made. And so up here, oops, I guess I didn't put a little thumb. So it's easy to, you can select using these tabs up here what quantities you would like to plot against each other, change the coding, et cetera. So in a way, that's analogous to the filter graph mechanism for those of you who have used that. You can interact with the data in real time, just pulling from the confirmed planets. There are also pre-generated plots that we do automatically that are available for you to look at or to use. Here's the thumb telling you where to get them. And these show things, I'm not going to talk about all of these, but the classic mass period diagram for known exoplanets automatically color-coded by discovery technique, et cetera. So we also just create an update on a weekly timescale, a lot of the kind of more popular diagrams that people use in talks and whatnot. Then, for every confirmed planet, there is what we call the confirmed planet overview page. And this is where we have a bunch of different tables giving different kinds of information. So just to highlight, here are planet parameters. So we see mass, radius, planet density, equilibrium temperature, replete with references, the orbital properties, transit properties. This one happens to be a transiting planet, down to stellar properties, et cetera. I'm only highlighting a few here to give you a general sense. There's much more information available. You can click on all of these references and see, get back to the actual literature. Should you want more than just what's in the table, whenever there's an orange row that highlights the default, this is what's displayed in the confirmed planets table for any planets that have more than one data set or more than one parameter entry in the literature. And you can actually access all of these in a confirmed planets interactive table way through what we call the extended planet data table. And there are also finding charts as well. This is from URSA, another one of the projects run locally out of IPAC that will produce these for confirmed planet hosts. Now I'm going to talk a little bit about that extended planet data table that I just alluded to quickly. Here, if you go down into the bottom left of the front page, you can search extended planet data. And here, what you're doing, instead of immediately just having a 1 entry per confirmed planet full table of all of the parameters for these confirmed planets, you can actually search. Here you can search specifically to find all of the data, all of the parameter sets, et cetera. For any individual system, you can search by survey, discovery method, et cetera. There's a bunch of options here. And then you click Submit. And you can see here one of the main differences is there are several rows, say, for HAPP 1, HAPP 11, 12, 13, 14. And now, if you're interested in looking at planets from a given survey, or all of the entries in tabular form for a given individual planet, that's one of the main functionalities of the extended planet table. Now, to kind of focus on why this talk is specifically relevant to this Sagan workshop in particular, I'm going to talk about one of the new features, relatively new, of the Exoplanet archive, and that's the microlensing planets table. So it's down here, hidden coyly, right at the bottom. There's a microlensing planets tab. And this looks a lot like the confirmed planets table. It's built on the same kind of infrastructure. And this was rolled out in an incomplete but first draft edition for the latest annual microlensing conference, which we hosted here at the end of January, early February this year. And one of the motivations is that there are a lot of observables, fit parameters, and even in physical properties that you're working with in microlensing that are not necessarily the same as many of the drivers for the RV in transit method, which have discovered, as we all know, the vast majority of known exoplanets to date. So I've just highlighted these, which we all know, again, tattooed on the back of our eyelids, some of these common microlensing parameters. So the Einstein crossing time, you're not going to find that in the confirmed exoplanets table. It would just be null for 96% of the planets. So this table has been created so that you can specifically interact with microlensing observables for microlensing exoplanets. T0, time of closest separation, angular Einstein radius, and on and on. There are a couple dozen more columns. In its current, actually, I should say one more thing. So right now, currently there is, even in just the default display of the microlensing exoplanet table, there's 1 entry per model. And that's so if you have any interest in comparing, we've discussed a lot of these degeneracies, comparing the fits for the different models, looking at what different physical properties might result from these different models, or even just trying to get a sense of maybe photometric or color parameters and how they differ. We are undergoing, currently, I'm actually helping lead an overhaul of this to do kind of minor UI tweaks, such as resetting the default displays, grouping the parameters, reordering column positions. And right now it's incomplete. There were about 35 columns, but it was only spanning maybe 10 or so planets to make sure that we catch up with the current state of microlensing exoplanet literature. So I'll put that kind of under the coming soon tab in the coming months. Keep your eyes out for a completed planets table. I'm going to quickly talk about ExoFOPs. This is an exoplanet follow-up observations program, or page. And it's not specific to microlensing. As you can see, it has interacted with Kepler, K2, and will with TESS. But I'm going to specifically focus on Campaign 9, which our excellent speaker yesterday gave a nice overview of. So the specific page for ExoFOP K2 Campaign 9, there are kind of resources on 2 different timescales, I would say, that were most useful and most relevant for this page. One was an observing log. I should say like an observing calendar, I think is the better way to describe it. So it's here under calendar, telescope resources. And all of the people at IPAC-NExScI worked very hard in the archive specifically to make this possible. So this is a zoom out. You're not supposed to actually be able to read anything. But what this is showing, if we just take a close look at the top, these are different telescopes on the left, their availability throughout the campaign, what kind of observation or observing windows are they going to be able to contribute? And then this is color-coded by what their band is. So this was a way to tell in real time what are the data availabilities, and then even post-campaign to figure out, based on when an event peaked, what kind of photometric data might already exist. Then this is another interactive table that during the campaign was keeping a running track of events that were ongoing, and now is basically frozen, given that it's been a year since the end of the campaign. But that was keeping track of preliminary best fit parameters for all of these events. Here we see these kind of T0, U0, TE single lens parameters. And if you actually were to look at one of these specific events, so clicking on, oops, yeah. Anyway, clicking on one of these links on the left, which are actually hyperlinks, you would see a large overview page, and we'll just zoom in a little bit, and it gives you in different tabular form in a way that's analogous to the confirmed planet overview page from the front page. A lot of information about the fits and even data that are available, so light curves from things, facilities such as UKIRT, LCO, and others that I'm forgetting, VST, that you could directly download through the ExoFOP. And I'm going to end this just by mentioning another data set that we've kind of alluded to in various talks throughout the workshop so far, and that's a UKIRT survey. So I'm throwing up just a Gilligan's Island recap of everything that we know about the UKIRT survey from 2015, 2016, when it was conducted in 2015 to support a Spitzer microlensing survey campaign, in 2016 primarily to help with K2's Campaign 9. And basically, the most important thing to take away from here is, I would say, the spatial coverage plot. So this is where the 2015 survey was looking. This is the 2016 survey in the blue squares. The K2C9 survey superstamp is here in pink. And then at the time, these were the proposed WFIRST microlensing survey target fields. So you can see there's a lot of synergy in these data sets. And as people have mentioned and gone over, one of the benefits of going to long wavelengths is that you're mitigating a lot of the extinction, and that sets you up for making near-infrared source flux measurements, which JP gave a great overview of what kind of leverage that gives us for measuring physical parameters. There is a UKIRT survey that is ongoing in 2017. It's 1 or 2 weeks away from wrapping up. Yossi Schwarzwald is the lead for this. So here I'm showing just the footprint for the 2017 survey, color-coded by cadence over here, and then it's overlaid on a K-band extinction map over here. And I'm actually not going to say too much more about that, and just divert everyone's questions to Savannah Jacqueline, who gave a poster pop earlier today, and she's been working with us very hard, as she mentioned, to do a lot of the analysis of the UKIRT data from the past 2 years. The reason I mention it in this talk, and I'll just end here, is that another ongoing project that I and the rest of the Exoplanet archive team is working on is to host all of the UKIRT data projects. So through the 2017 season, this will include 3 years of time series, H and K band, roughly nightly cadence epochs. And what I'm showing here is the SuperWASP data interface. This is how you would search the light curves that we're hosting for them. And we're basically going to do the same thing, but for UKIRT. So these will become publicly available. That was hard-coded into the charter of the funding for this experiment. So I'll put that under the tab of coming soon as well. So I'll end there, say thanks, and take questions. Yeah, so we tried to be as apolitical as possible when there are disagreements in the literature. So let me see if I can actually go back. When we're deciding what entry for a given planet is default, so that's this orange highlighting here. Sorry, I'm using the wrong thumb, that's why it's taking so long. Yeah, so this is a good example of a set that has multiple values here, for period, semi-major axis, inclination, eccentricity, a lot of the common parameters. The default is either going to be the paper that has the most complete set of data. So if they have, derived the most parameters for that system in terms of sorry, I'll say publish the most parameters. Yeah, exactly.
Everything in there has been published.
Well, I would say complete data. Different authors can decide to derive different numbers of parameters based on different kinds of data. That's all.
Yeah. So I'll say n. First criterion is n sub parameters, and then if there's still a disagreement about what to be default, it will be which one is more precise. That's kind of criterion number 2. If 2 different papers have included the same number of parameters or very similar, we'll go for default with whichever one is providing more precise measurements of those parameters. And as you correctly mentioned, that's going to be the one, this orange highlighted here, that's going to be the default for all of those parameters. See, this is Barclay 2015 again for all of these tables here. And that's going to be the one entry that's displayed in the confirmed planets table. Though again, in the extended planets table, you'll have all of them. But yeah. Does that answer?
Yeah, and then
Okay.
the general broader question, what do you do for things where there's been many papers saying, oh, there's some uncertainties on these? Do you include that in any way?
Yeah, that usually comes down to a more subjective discussion amongst the science team, and often just contacting various authors to see if that's something that can help resolve the issue. Yeah, we try, the mission of one of the missions of the Exoplanet Archive is not to decide any of those things, but to just, see if the literature, the authors of the data can answer the questions themselves. So I wouldn't say, we internally have our own criteria for what gets ingested. So, and we're actually in the process of potentially revising it. Right now it's a mass threshold, which is set at 30 Jupiter masses, and this was set before my time, but to allow for any objects that might, whose error bars or uncertainties on mass might take them into the deuterium burning, under the deuterium burning regime. Because of that, there are objects, I'll say, that you would find here that you wouldn't find in EU or .org, and vice versa. We're probably going to revise that in the next couple months. Again, that's coming down to a full science team discussion. And you had another question that I forgot, but I had an answer to.
Well, essentially, yeah. It's just whether you cross-check the other archives. There's communication between different archives that happen.
Yeah, I would say we're not, we're independently trying to, our goal is to independently host a repository of data. We will link, it looks like I didn't take a long enough screenshot. So if there is an entry on exoplanets.org or exoplanet.eu, we will include links to those web pages, but we're not doing any sort of cross-check or validation because their ingestion procedures and criteria are different, maybe in subtle ways from ours.
Any other questions?
I guess range of seller properties included in the table, just everything that's available? Or?
Yeah. As you won't see at the bottom of the screen, there's a much longer. This page is very, very long. And yeah, there's anything from TEF and log-G to V-sin I rotation measurements. Yeah. Yeah, it's really cool. Yeah.